Hello, this is Team Innovators 404 from JSS Science and Technology University. Our problem statement is Variable Location Tracker during disaster.
Natural disasters occur rarely, but these rarely occurring natural disasters take many lives. One of the main reasons is for not getting help in such a situation. Imagine a person is stuck in natural disaster like floods or tsunami. The person will be stuck in such a location that he cannot be found. He may have a GPS tracker which detects the location through the satellite. But if we have say like GSM module or if he wishes to send his location to any specific person, he cannot as there will be no network connection during such situations. Since mobile signals are LTE based, it loses its connectivity in such disaster situations. So, ours is a project based on building a variable device consisting of a GPS module, Arduino Uno, LoRa module, and a OLED display. We are using LoRa, which stands for long range, which can be configured as both transmitter or a receiver based on our requirements. LoRa does not require mobile-based signals to transmit its data. So it's connect through its own antenna. So this will be helpful in such a situations. So what our project do is first GPS module tracks the location of a person wearing the device and is connected to a Arduino, which is a microcontroller here, which has the LoRa module configured as a transmitter and sends the specific location of a person to the receiving side, and the same location will be displayed on the OLED display. Here display is optional. If we want our device as a waist device like a belt, there is no need of display. If it is like a wristwatch, we should have a display. The location sent will be received by the LoRa configured as a receiver at the receiving side without any external transmitter or a receiver. Then the rescue unit which gets this location on an app can easily help a person stuck there. So, to what distance this LoRa module send and receive the signal? The transmitting side which sends the data can be received by the receiving side up to a range of 10 miles. So he can get help from the rescue team where up to a range of 10 miles far away from the network area. There is no need of making receiving unit for each transmitting device. Many people stuck in similar situation can send its data to a single receiving unit. So LoRa has it will be configured as a receiver can receive signal from 1500 transmitting device. That is 1500 people's location is being sent to a single rescue unit up to a range of 10 miles, which is very helpful in such kind of situations.
Now I will be telling why we are using LoRa instead of any other devices. LoRa stands for long range. The main idea of our project is if a person is stuck far away from the network signal place, that LoRa module should detect that signal and should catch it. LoRa as experimental result shows that maximum range can be up to 20 kilometers. So take an example of a fisherman. If he is stuck in somewhere 10 kilometers from the coastal side, in that situation also, the LoRa sends that signal and catches it at the receiving side. Since this is the reason we are using LoRa and which has high range than other modules. This is our design. We are using LoRa RA02 module and is connected to the Arduino shield in this fashion. We are using a LM317 voltage regulator which regulates the voltage from 12 volts to 3.3 volts. We can have a LCD display in case to just to display the location, that is latitude and the longitude. The LoRa left here, the main is the device which this is the transmitter device that that contains a GPS, a LCD display and the Arduino shield and the LoRa transmitter. The LoRa right contains the LoRa receiving module and the app which is connected through the mobile. This is the main design. The simulation will be shown the next. This is the simulation for our project. Here I have to mention that we are using Proteus 8 professional simulation software. This software does not provide LoRa libraries so that we can use it for the simulation. So what we are doing is we are using a simple transmitter device here and simple receiving device to show the simulation. But in the actual prototype, we will be using the LoRa. Since this Proteus doesn't provide this library, we are not able to use it. This is the connection which we are making. This is the Arduino shield. Instead, in the actual prototype, we will be not using complete Arduino. We will be using only IC to make it small. Since it has to be a variable device, the device should be small. And we are using a GPS module. Instead of such a large LCD display, we can use a small LED display which is small and which will be helpful for our device. How does this project work is, as soon as the button is pressed, the GPS module which already detected the location will send its data through this transmitter, and the same will be received at the receiving side and shown on the app. Here, just for the sake of the simulation, we are showing it in a serial monitor. In a real prototype, there will be app which will be connected to the receiving unit and will be shown to the rescue team so that they can rescue people. This part on the left side will be the transmitting unit and will be mounted on a PCB. We will be designing a PCB so that the variable device is small and all these devices can be mounted on it. Here we can see that the transmitting and the receiving side has an antenna. What we are doing is we will be mounting that antenna on PCB2 similar to that of ESP8266 that has a mounted antenna already in it. This is the result of our project. As soon as the push button is pressed, the help seeking message saying that need help stuck in this location with the latitude and longitude will be sent to the receiving unit to the rescue team so that the rescue team can detect this location with latitude and longitude and help the person stuck in the situation. This is the app which will be with the rescue team on the receiving unit. As soon as the person stuck in the disaster sends the location, the LoRa module at the receiving end receives this signal and shows the location on the app. This is a simple message which I am showing here from laptop to this app. So this is our project which we have mainly focused on building a device which sends and receives the signal even during disaster when there is no LTE signal or mobile message signal. Thank you.